Oh, welcome, ladies and gentlemen. I don't know if we could start off a great year with a better song than that. And, well, we're going to get a kick started here. This is our first of 4 videos to help you through your summer assignment and take a little stress off you. Hopefully you've seen the Zap Rule before, and tonight we're just going to get comfortable using the same language and just lay a real strong foundation. And before we even do that, I want to go over a few prerequisites that hopefully you remember from your days in Algebra 2. And I just want to go over our log properties, and then I'm going to show you some potential bear traps. But if they want the, the natural log of a times b, we could expand that and say that's the natural log of a plus the natural log of b. And of course, if they want the natural log of a divided by b, we could expand that, and hopefully you're in cruise control and this is all coming back to you. And of course, if they've got natural log of a raised to a power of, let's say, m, we could move that exponent down to the coefficient, say m times the natural log of a. All right, and then on the flip side of that, I want to go over some exponent properties. And let's see here. So for instance, if we have e to the a times e to the b, so we've got the same base, we could condense that and say e raised to the a plus b power. Let's see, if we had e to the a divided by e to the b, that's equivalent to e raised to the a minus b power. Or if we had e raised to the a and that whole quantity was raised to the b, that's when we would actually multiply those exponents and call it e to the a times b power. Now the one bear trap I want you to watch out for, and I'll try to trick you on this once in a while on the quiz, is I may give you the natural log of the quantity. Instead of a times b, I'd say a plus b. And the directions may say something like expand as much as possible. And the actual answer is we can't expand that at all, and we would simply say that that one is done. It's impossible to expand what's there. Okay, so watch out for that bear trap. So building up to our Zap Rule today, I asked this question first. What is the relationship between the function y equals e to the x and his counterpart y equals natural log of x? And that's really the foundation today. And I'm having have a little talk with my stylus pen here. It's not really cooperating. But anyway, what is the relationship between these two rascals? And if you know that they are inverses of each other, then you've got the foundation for a great lesson today. All right, they are inverses of each other. In essence, they're going to cancel. So the Zap Rule, one of the things I refer to it as one of the coolest rules ever. It's the idea that inverses cancel each other out, just like we said on that last slide. The idea that inverses cancel each other out, or in other words, they undo each other, basically. So you've seen the Zap Rule a lot throughout your math career, and we've never referred to it as such. But let's say we had this equation that said, you know what, I want to take x and I want to add 2 to it, and then I want to subtract 2, and we'll set it equal to 7. Well, actually, we've got the Zap Rule right here. The idea of adding 2 and then subtracting 2 are inverses of each other, and so we zap, they cancel each other out, and x equals 7, okay? So again, we're not doing anything too, real crazy. Let's take another Zap Rule you've done earlier in your life. What if we multiplied x by 2, and then we decided we're going to divide by 2 and maybe set it equal to, who knows what. But again, the idea that we're going to multiply by 2 and then divide by 2 is, again, inverses of each other. Multiplication and division are inverses of each other. And we've got the Zap Rule, and they cancel, and you get x equals 10. So the same thing applies here today, except, it's going to be the natural log of e to some power. And it's the idea that the natural log and the e are inverses, and they cancel out, and you simply get x. Or just flipped around here, maybe we've got e raised to the natural log of x power. Again, the idea that they're directly in contact, e and ln are directly in contact, they cancel out, and we get an x. So that's basically the Zap Rule in its simplest form, and we're going to try to apply that to some slightly more challenging problems. So here's our first slide, and I gave you 2 super basic examples that are going to give us some good feel for the Zap Rule. And the directions for both of these simply say simplify, that one S word, simplify. And so here's what I'm going to do on the first one. You'll notice that the natural log is directly acting on the e, and so the Zap rule does apply, and we're allowed to cancel those out, and we say that expression is simply equivalent to 3x squared, and that's it. And then on our second one, again, the e is in direct contact with the natural log. They cancel each other out, and that expression is equivalent to simply the sine of x. Again, that's it, and that's what we would consider the simplified version of those expressions. So we're getting slightly trickier. Again, the directions say simplify, and the key here is we just have to rewrite them one time before we can actually apply the Zap rule. See, on this first one, the Zap rule doesn't apply because of the 5, the location of the 5. We would say that the e is not directly in contact with the natural log or directly acting upon it. So what I'm going to do is I'm going to rewrite it using my log properties, and one of my log properties says that this coefficient can move to the exponent. So I'm going to rewrite it as e raised to the natural log of x to the 5th power. Now they're directly in contact. We could use our Zap rule now and say that that expression is equivalent to x to the 5th power. All right. There's the pen working. All right. So number 4, again, the natural log and the e are not in direct contact with each other. The problem is we have this 1 in the numerator of a fraction, so we're going to rewrite it so that it's not in the form of a fraction. And we're going to say it's the natural log of simply e to the negative x squared power. Now the natural log is acting directly upon the e, and we can say that they cancel each other out, and our expression is equivalent to negative x squared. Well, I'll tell you what, you've done a good job of hanging in here in this first video, and this is our last slide for the night, and we've graduated to the downright nasty ones, and these are 2 of my favorite ones that we're going to see. And again, the directions simply say simplify. And the first thing you'll notice on number 5 is that the natural log is not acting directly upon the e. And so what we're going to do is we're going to employ our natural log properties that allow us to expand because we see multiplication, because we see the product between x cubed and e to the tangent of x power. We could rewrite this as the natural log of x cubed plus the natural log of e to the tangent of x. Now, looking at the first term here, there's nothing I can do to simplify that. So it's simply going to stay the natural log of x cubed, and we just have to be content with the fact that I can't do anything to that term. However, the Zap rule does apply to the second term. The natural log is acting directly upon the e. They cancel out, and we simply get the tangent of x. And right there, ladies and gentlemen, is our most simplified answer. All right, last one for tonight. Again, the e is not directly in contact with the natural log, and so we cannot use any Zap rule yet. However, with a little bit of creativity, we can do so. What I'm going to do is I'm going to use a trick that I call decomposition. If you go back to the first slide and look at one of our exponent properties, you'll recognize I'm going to use that first one on that list, except I'm going to go backwards. I'm going to go from the right side to the left side, and I call that decomposition. Check this and see if you agree. This is really e to the radical x times e to the 2 natural log of y power. You know, traditionally we would give you this expression and you would move in this direction, except we're just doing the opposite, and that's why I use the phrase decomposition. Again, the first term there, I can't do anything with it. And in fact, the second term, I can't do anything yet until I move the 2 to the exponent of y. Now I can use the Zap rule on the second term right there, and just using good math etiquette, I'm going to put the y squared in front and then e to the radical x second, and it's the product of those 2 terms, and that is my most simplified version of what was given to us now using the Zap rule. So ladies and gentlemen, good luck. If you don't agree with any one of my answers or something, feel free to text me. I believe my number's on that cover sheet, that nice pink reddish sheet, and good luck.